Hello, everyone, and welcome to another session of Fronius webinar. Yes, it's indeed a pleasure to meet you all today, and apologies for the late start of the webinar. We kind of had a few technical hitches, but then that has been taken care of. I will be taking you through the first part of this webinar. Of course, I'm not going to be doing it alone. And of course, the topic for today will be installation and commissioning of Fronius Tauro inverters. And to do this with me today is David Mwangi. Okay, so please, I would love you to indicate by raising your hands if you can hear me clearly, please. And we'll now move to the next stage of sorting whatever issues there is. Okay, thanks, Jack, for the notification. Yeah. Turns out that there's a new feature, probably an update on the platform that's kind of constituting a bit of hitch with the free flow of the presentation. So we'll try to sort that out, and then we can continue with the presentation eventually. Great. So, yeah, I think we're back on. So, like I said earlier, today's presentation team is, of course, with me and David. David is the technical sales advisor for the Eastern Africa region. And then, of course, myself, Cyprian Okolo, who is the technical sales advisor for the Western Africa region. Let's quickly take a look at the agenda for today. So it's all about the Fronius Tauro today. So we will be introducing the inverter, of course, with the power classes and topologies available. And then, of course, we'll now go through proper installation of this inverter, give you some information about the commissioning, dynamic power control, monitoring, service and maintenance, and then, of course, some further information afterwards. So just to give you a brief intro, the Fronius Tauro is basically a robust inverter that's been designed by Fronius to take care of our large-scale PV system customers. It turns out to be a very durable and economically viable choice. And just in summary, the Fronius Tauro is an inverter that has been designed to perform. And then, of course, the coming details that we're going to be giving you about the inverter would, of course, prove these initial statements. So going forward, let's now quickly talk about the power classes that we have in the product portfolio. First up is the Fronius Tauro Eco. The Eco there basically means economical. So for the Tauro Eco, we have two power classes, that is the 50 kilowatts and the 100 kilowatts power class. Both of them have integrated one FPP tracker and then have MPP voltage window or range of 580 to 930 volts. Depending on the power class you're going for, it ranges between 74 and 103 kilograms in weight. So this logically means that if you're going for the 50 kilowatts, it's approximately 74 kilowatts, and then 103 kilowatts approximately for the 100 kilowatts power class. Yes, then next up is the Fronius Tauro standard, or probably you could just call this Fronius Tauro. Just to differentiate it with the Tauro Eco, this is a typo. So for the Fronius Tauro, just pick up my highlighter here. Great. So this is basically a typo. So it's basically called the Fronius Tauro. For the Fronius Tauro or Fronius Tauro standard, it has just one power class, which is the 50 kilowatts power class. It's integrated with 3 MPP trackers and has a wider MPP voltage window or range of 400 to 850 and weighs approximately 92 kilograms. So what makes the Fronius Tauro special? First off is easy installation, as we're going to see subsequently in the coming slides. It has easy and rapid service. And then we have this wonderful option, that's a daisy chaining option, which makes it very, very economical when implementing large-scale installations, especially when it comes to BOS cost savings. And then we have onboard system monitoring hardware. And then it comes with a flexible system design because of its integrated cost reduction features. And then, of course, it is extremely robust, as I've mentioned earlier. And this means that you can actually install it outdoors, unprotected. So meaning that you can install it under the sun or under the rain, whatever the situation may be. And you can be sure of getting optimal production from this very special inverter. So let's now take a look at the topologies available. So first off is the central, basically there are two topologies possible. So we have the centralized and the decentralized topologies. So for the centralized topology, as you can see from the left-hand side, the image on the left-hand side, it basically entails a centrally located inverter system. That's obviously where the name was coined from, per se. And then we have the decentralized system. In this case, you have the inverters scattered around, but in this case, they are situated close to the modules. So in this case, you can use your DC combiner boxes to collect all the DC power and then channel them directly to centrally located inverters, as you can see. And then in this case, you can have the inverters installed pretty close to the modules and then have them connected directly to the inverters. Good. As I mentioned earlier, we talked about design flexibility. So let's talk about this flexibility on the DC side. So on the DC side, it is possible to have a pre-combined topology. In this case, you can actually implement a system using DC combiner boxes. Obviously, we know that when we implement a system using DC combiner boxes, we're going to have a collection of larger DC cables. So a provision is obviously made on the inverter side, the DC side, to ensure that we're able to accommodate whatever is coming from the DC side. So we have cable cross sections up to 95 mm squared. Of course, that is big enough to accommodate anything coming from the DC side. So still on the DC side, if you're now implementing using the decentralized or direct topology or system design, we have these MC4 plugs that enables direct connection from the respective module strings. Now, having said so, let's talk about its cost effectiveness when it comes to cable handling or cabling, basically. So basically, if you have a collection of inverters that are installed, say, for example, in a decentralized system design, you would have them at various distances from the main AC distribution frame. That means that you'd have to run separate and consecutive AC cables from the inverter respectively to the main distribution frame. Or you can have something like this. So you can have the inverters AC daisy chained and connected singularly to the main distribution frame. Now that's special. So this is made possible because of this special feature that is the AC daisy chaining option of the Fronius Tauro. And this, of course, lowers cable cost due to the interconnection of Tauro devices on the AC side. So it is possible to have a maximum of 200 kilowatts that are interconnectable. Okay, so this is basically a recommendation. You're not supposed to go beyond 200 kilowatts per interconnection, let's say. That means you can have 2 units of 100 kilowatts Tauro or 4 units of 50 kilowatts, as is represented in this case. Or you can have a unit of 100 kilowatts and 2 units of 50 kilowatts, depending on your system design regime. Good. So going forward, let's put it in a bit of a perspective. Let's see how cost effective this becomes in the practical case. So let's have this scenario of two Fronius Tauro inverters installed. One is 100 meters away from the main distribution frame, while the other one is 50 meters from the distribution frame. If the AC cable is going to be laid, of course, you're going to have a total distance of, or total length cable of 150 meters. Now, you would also have to ensure that you have AC disconnectors, respectively, of 160 amps that will be able to accommodate the current of the load current, obviously. So that's the first scenario. Now, how about another scenario? In this case, in order to cut cable costs, we now have an AC combiner box somewhere in between. So let's say this AC combiner box helps in reducing the cable length from 150 meters to 103. Yeah, that's considerable, right? But then note that you're going to have an extra cost, extra component cost of the AC combiner box. And that would mean that you would have to implement an AC combiner box of 320 amps that should be, or that would be enough to accommodate the current, right? So that's an extra cost. Or you can go with something as simple as this, simple and effective, using the AC daisy chaining option of the Fronius Tauro inverter. In this case, you not only have a shorter cable distance, you also eliminate the use of combiner box. Now, how's that? So let's talk about the flexibility in terms of cabling still on the AC side. Great. So in this case, you have various options. So you can actually have a single core option where you have 5 inputs, of course, with the respective phases, ground and neutral, all ranging between 10 mm diameter to 28 mm diameter cross-sectional area, cross-sectional distance per se, or length. And then, of course, you can also have a multi-core cable ranging from 16 mm to 61.44 diameter length, as you can see. Good. Now, it is possible to have an AC disconnector integrated right inside the inverter. Yeah, right inside the AC compartment of the inverter. So, of course, this is an optional choice, and of course can be configurable ordered X factory. So all that's needed to be done is to include it in the option while making your device configuration. I'm going to tell you more about that in the subsequent slide. So, but of course, as you can see in this picture, the device is in the on position. So please ensure that the device is in the off position when you're working within the device, for obvious reasons, of course. So let's talk about DC-AC surge protection device, which of course integrated right inside the inverter. And then not just that, we also have empty space, which has been made possible for cases where we have integration of third-party components, like say LAN switch, your LAN switches. You can actually have them installed right inside the inverter. And once this is done, it of course accords that particular component the protection that is accorded the entire components inside the inverter. So so basically that's it. And just to let you know that the SPDs comes in different types. We have the type 1+2, and then we have the type 2. Both of them, of course, assuring lightning and overvoltage protection, depending on your region. So please, for cases where you have a higher frequency of lightning, it's of course recommended that you go for type 1+2. In a region where you have lower lightning frequency, you can of course still go with type 2, because it also comes with lowered lightning protection capacity. Good. So introducing the arc fault detection. This is actually a new feature that actually rolled out a couple of months ago by Fronius that guarantees you maximum safety on the DC side, of course. Because, of course, there are cases where we have arcing, especially on the DC side. Now, with the AFCI, that is the arc fault circuit interruption, it makes it possible to prevent any incidences with this integrated technology, because this is actually a self-trained algorithm that helps in the continuous uh, protection and, of course, an improvement in this line of protection. This is, of course, because of our many years of experience with ACTS, because as you all know, and for those who don't know, Fronius actually has three business units: our charging unit, our welding units that was founded since 1950, and then, of course, our solar energy unit. So with the experience we have with ACTS, it is, of course, integral that we implement such protection, and then with that accolade, we're able to provide maximum safety and protection in this regard. But please note that this protection, for now, is available for system designs or string designs of 20 amps fuse protection. It is, of course, orderable X factory. Now, let's look at have a quick look at the design flexibility, starting with the D option, of course. So with the D option, if we look closely, you can see that I've mentioned this before in the previous slide, but then having a closer look at it, you can see that in this case, we have the inverters pretty much installed close to the modules, right? And then, of course, you would expect to have the MC4 plugs there present for you to now connect the modules directly to the inverter. But then if you look closely, we have implemented the AC-daisy chaining option here. So we have 8 inverters here, but if you have a close look, you have just 4 AC cable runs to the transformer, thereby reducing the cable cost, of course. So AC-daisy chaining has been implemented in this case. So instead of 8 cable runs from the individual inverters, we have just 4 cable runs. Good. So just to mention here that, of course, you have your DC MC4 plugs made available, just to inform you of the number of strings that are available. So for the 50 kilowatt devices, we have 14 strings, while we have 22 strings for the 100 kilowatt devices. Good. So how about DC cable connections? As you can see, as I've mentioned in the previous slide, you have 14 strings for the 50 kilowatt devices and 22 strings for the 199 kilowatt devices. Good. So that means going further, you can see that for the Tauro 50 kilowatts, which has 3 MPPTs embedded, it is possible to have three inputs, that is PV1, PV2, and PV3. Then for the echoes, we have for the Tauro Echo 50, we have 2 inputs, 2 DC inputs, that is PV1 and PV2. But then for the Tauro Echo 100, we have 3 PV inputs, DC inputs, that is 1 PV1, PV2, and PV3. Yeah, so with the increments or the evolution of high power modules, we at Fronius, of course, are not static. We are also dynamically improving our systems. So we now have a 30 amp fuse option to take care of higher power modules. Good. Let's now talk about the Tauro Echo P option. P obviously for the pre-combined option. So in the pre-combined option, like I've mentioned earlier, this involves the use of DC combiner boxes. As you can see, let's just have a look at it down here. We can see that your PBs goes in from one terminal, and then at the end of the day, from the breaker, the protection breaker, you're going to have larger dimension cables coming out from it that are going to be the input to the inverters. So as you can see, provision has been made, and then right inside the inverter on the DC side, we have what we call V clamps. So these V clamps makes it possible for you to have connected 25 to 95 squared cable. So having a close look at it, at the inputs for the Echo 50 and 100 kilowatts pre-combined versions, you can see that we have the respective inputs, as you can see, PV1 and PV2. That's for the inputs. And then for the Tauro 50 kilowatts, we have 3 inputs, respectively, for the MPPTs. That is PV1, PV2, and PV3. So we're now going to take a look at a couple of layout examples of all what I have been saying so far. So let's have a look at a decentralized system layout. So in this case, we have a free field layout of about, say, 100 by 100 meters squared area. So in this case, we have implemented the Tauro AC daisy chaining, as you can see in this case. And then this particular topology or layout comes with various advantages, as you can see. First off, of course, you don't have to use any DC combiner boxes because the inverters are right where the modules are, so you can connect them directly. Of course, the AC cables you're going to run are going to be lower, so therefore lowering AC cable costs. And then, of course, you have less installation effort, especially when it comes to cable laying. Like I've mentioned earlier, we're supposed to have run, say, 8 cables for the AC side, but then we're just laying 4, which saves a lot of effort and, of course, cost. So how about this? This is a centralized free field layout. Yeah, so in this case, we have long DC cables. So as you can see, we have long DC cables coming from the DC combiner boxes. So, and we know that with DC cables, we have lower um, um, voltage losses across the cable. Okay, so of course, which leads to less power losses along the cable length. And then, of course, it is easy to access all the inverters for installation and commissioning purposes, and also for maintenance purposes too. Because if we just take a few steps back, considering the space in this area of installation, if you have to carry out commissioning processes, it's going to take you a lot of time because you have to go into the individual inverters where they are to carry out this process. But for the centralized version, they're all located in one central location per se. And then, of course, it makes it pretty much easier for the installer to have access to the inverters to carry out any of these processes. So it is also possible to have a combo. Yeah, you can actually have a both decentralized and centralized combinational layout, as you can see in this case. So we have an on-roof installation that is implemented using, the DC combiner boxes going to their respective inverters, and then you have them on the AC side daisy chained and connected to the inverter. And we have a scenario where we have another installation site that is far away from um, the, the transformer per se. And then in order to reduce cable cost, you can of course use half of the dimension and go with a double cable laying along longer distances to reduce um, voltage losses along the cables. Good. So far, so good. Let's look at cabling options and power loss calculations. Yeah, so that's actually a very, very important point to discuss. You might want to ask, so given the fact that, there are losses along the AC cable lines more than what we have on the DC side, or DC cables, what could be the maximum AC length cable that can be run, and at the same time ensuring that the power losses along the cables are not more than 1%, or most importantly, we might say lesser than 1%. Yeah, so we have actually done our homework in this end and have actually come up with an answer to that. So taking into account the cable losses and of course trying to ensure that your cable losses are below or is below 1%, a maximum AC cable distance of up to 125 meters is possible. Okay, and I think that's a very, very good one, if you ask me. But then, having said that, it is also possible to have systems that are designed for losses higher than 1%, but then lower than 3%. But however, there are no normative requirements that prohibits installations going higher than 3%. But of course, the lower the losses, the better. Good. So how do we now select the best Tauro option for the system we want to design? We have also taken a look at this and have done sort of a simulation and costed Tauro system over 20 years, inclusive of the losses. So we're looking at the two options, that is the direct and the pre-combined, taking into consideration the cost per 200 kilowatts PV block. So in relation to the distance from the PV system to the main distribution frame, that is where the crux of the matter is. So depending on the distance from the PV system to the main distribution frame, as well as the cost of other components, it behoves that at the beginning of the project, per se, inclusive of CapEx and OpEx, we would see that the direct option is, of course, more economical, but as the length continues to increase, it becomes more expensive, right? Conversely, for the pre-combined version, you can see that it costs more in the CapEx or at the beginning stage, inclusive of the CapEx, of course, but as the length or the distance between the PV system and the main distribution frame goes beyond a certain point, it becomes economically viable more than the direct version. So we have an equilibrium point per se, which is the 50-meter mark. So in explanation of this particular diagram or graph, it means that for direct systems, if you're not going to go beyond 50 meters, then the direct topology implementation turns out to be much more economical. But then if you're going to go beyond the 50-meter mark, then the pre-combined topology becomes much more economically viable. So to summarize, if you're going for short distances, go direct. For longer distances, go with the pre-combined version. Yeah, so this is basically just reiterating the importance of the AC-daisy chaining option. So it comes with all the advantages that we've mentioned earlier. And then most importantly, when it comes to return on investment, this tends to be a very hot topic. And when you have an option that can guarantee you the quickest return on investment time, then I believe it's an option for every installer or prospective client to go with. Let's now have a look at how we can properly install the Tauro. Well, first of all the groundworks has to be done. And then once they're done, all you need basically is a Tox 20 or Tox 25 screwdrivers, of course, your quick start guide, and then your commissioning device. It could be a smartphone or a tablet. Of course, you would need to install in it the Fronius Solar Start app, which is an app that can be used to install all of our Fronius product portfolio. So in terms of transportation, yeah, it is possible to actually have it lifted by, of course, a lifting device. Note that it weighs between 74 to 103 kilograms, depending on the power class. So we have made provision for holding eyes at the ends to ends of the inverter. So please ensure that these holding eyes are made use of. Now, how about location? Yeah, so it's a rugged device that can be installed both indoor and outdoors. So, and of course, can be installed within this temperature ranges, that is minus 40 degrees as low as that, up to 60 degrees outdoor ambient temperature. So for the installation site, it's nothing out of the ordinary. Please ensure that you have it installed um, uh, on the shed per se, because that would of course increase the ambient temperature performance per se. But then that's notwithstanding, it can also withstand harsh temperature. I'm going to show you that in the subsequent slide. It has a protection, ingress protection class of 65, that is IP65, meaning that it can protect against the ingress of water particles and dust. In terms of installation um, altitude, please don't go beyond 4,000 meter above sea level, but even that figure is an incredible one, honestly. Because of the sound it makes, that is the fan, while implementing active cooling, it is recommended not to be installed in bedrooms or in the sitting room. Please ensure that you don't install it on the dusty surfaces. Ensure that they are clean. And because of the corrosiveness of toxic substances, it is advised that we install them at places that are not too close to these elements. In farm barns or sheds, we know that farm animal dungs constitute of ammonia, which tends to be toxic in nature. So please avoid installing them in such close proximity with such um, animal dungs, basically. And then because of the ambient temperature of greenhouses, it is also recommended not to be installed inside of the greenhouse. Mounting position, also nothing out of the ordinary. Just don't make modern art out of it, as you can see in this case. It can be installed using the floor mount rack, as I'll be telling you in the subsequent slide. Apart from that, you can have it installed upright, that is vertically or horizontally diagonal, per se, or vertically diagonal, with the front facing upwards, of course. Good. Like I mentioned in the previous slide, it is possible to have floor mounting racks, as you can see in this case. So it is, of course, orderable using the Fronius Tauro configurator. Yeah, so it's also possible to have MC4 connector cover, as you can see. So this helps to protect it from snow, weather, or corrosion. And this, of course, also orderable. And then, yeah, these covers can easily be screwed on the body of the inverter. So this is basically to give you just a summary of how inverter can be mounted. So ensure that you have your fishers ready in the right position, and then have the floor mount rack installed, screwed properly, and then afterwards you can now have your inverter installed. Mind the weight, of course, so you can have as much people as possible. Well, basically 3 is okay. And then ensure that you have the screws to hold down the inverter underneath. And once that is done, you're basically ready to continue on to the next step of the installation process, which is more or less the wiring. So this is just a summary of the video you watched earlier. So just to note the distance, in case you're having a wall installation, ensure that you have of multiple inverters, of course, ensure that you have these distances implemented while doing so. Yeah, so we tend to implement active cooling for all our inverters. Active cooling ensures that the inverter operates optimally even under the harshest conditions. This means that we've come up with a cooling process that eliminates hotspots right inside the inverter. So with the double wall system that we've implemented, you can have the inverter operating optimally, even up to temperature levels of 50 degrees ambient temperature. And with this, we're able to record 13.5 degrees less than what it was than what it would have been because of this double wall implementation. Yeah, that's very true. And the next slide will tell us how we'll be able to achieve this. So with the double wall implementation, we actually had this technology tested using the AFCI solar simulator. Now with the double wall concept, you can see from this respective outlay or outputs in terms of ambient temperature record, cover connection area, and the inverter interior, we were able to record 13.5 degrees lesser temperature with the implementation of the double wall. So next up is the wiring. So here we're going to see how the wiring is done on the DC side or the DC compartment and on the AC compartment of the inverter. And to do this will be David, whom I will be handing presentation rights over to. David? Okay, I think, the technical hitch we've been having earlier is still kind of preventing David to take over. But whenever you're ready, David, just let me know. But in the meantime, I'll just continue with the presentation. So let's have a quick look at the wiring. So if we have a look at the, just want to give us a closer look. Great. So this is basically how the inverter looks like once you take up the front panel cover. So this is basically, use my highlighter again. So this is the AC compartment, while this is basically the DC compartment, okay? Still, I think it would be better to have it up close. Great. So this is the DC, while this is the AC. So a close look at this from the fuses. These are fuse boxes. So this is obviously a direct topology inverter. So this is a D version. Okay. So cables actually come in in this case, from the MC4 plugs and then connect directly. So these cables are obviously coming from the respective strings of the modules, and then they are now connected to the DC disconnectors via their respective string fuses, as you can see in this case. Okay, so once that is done, the power goes in via the DC switches into the inverter, and then goes into what I great. So in addition, it is advised that we don't mix MC4 products per se, because once you do this, you might have mismatching errors, and then this of course can lead to DC arcs. Okay, so please ensure that you have uniform MC4 plugs and sockets. The one that is actually built into the Tauro is the one manufactured by this manufacturer, Stovely. Hello, David.
Stephen, I don't think the presentation is visible. Please check if you've shared your screen.
Oh, really? Oh, can you hear me?
Yes, I can hear you, but just check if you have shared your screen.
Oh, I see.
Yeah, yeah.
Oh, oh, I see. Oh, great. Thanks a lot, David, for that observation. So sincere apologies. Yeah, I understand that my screen wasn't visible. Yeah, so I guess it's okay now. Yeah, sometimes technologies tend to, what do I call it, misbehave. But then, yeah, we can do our best to ensure that we have it up and running. Good. Okay, so just trying to sort out some of the screen effects. And yeah, apologies once again for the screen not being up all the while. So let's continue with the presentation. So in terms of module current, like I've mentioned earlier, we now have a provision that now is able to handle higher DC module current capacities. So yeah, so for cases where you have um, um, your MPP max current of 22 amps, it is of course recommended that you go for the 30 amp fuse. Yeah, so this is because of the evolution per se of module cells, right from the M3, M4, M5 up to the M12. All these having their respective current capacities ranging from 9 amps, 10 amps, and then in this case, we're having up to 18 amps module capacities. Let's quickly have a look at DC wiring for the Tauro pre-combined. So for this, um, this, of course, involves the implementation of DC combiner boxes. And then V clamps, of course, are used in this case to collect the DC cables, as you can see. For the 50, 99, and 100 pre-combined versions, usually have the PV1 and PV2 implemented. And then for the 50 kilowatts um, standard variant, you have the 3 inputs active. Now, in terms of permitted DC cable cross-section area, for the Tauro standard, the direct version, of course, for the direct version, we all know that we implement direct connection from the modules to the inverter using the MC4 plugs. So you have 2.5 mm to 10 mm cable cross-section area. And then for the pre-combined, we have 25 to 95 mm squared on the DC side, of course. Temperature resistance cable must be at least 90 degrees. So please ensure that you have this option checked. And yeah, I was mentioning V clamps, but while I was discussing about the AC side, but this time also implemented on the DC side, it is possible to have these cables accommodated within the same V clamp uh, grasp per se. This is possible because of the flexible nature of the V clamps. Okay. Now, for smaller diameter cables, as you can see in this case, all you need to do is to reverse the direction or the position of the V clamp. That enables you to have a good grip of lower cross-sectional cables. But for higher cross-sectional cables, you can have the V sections facing one another, as you can see. So you can take this as an inverted V, and then the lower side as a normal V. But for the lower cross-sectional cable, you now have both V's in the normal position per se. So with this innovation, we are able to accommodate cables of over a wide area of cross-sectional uh, um, dimension. We've not stopped there. It's also recommended to have these various cable types for these connections. So we have the solid round conductors, the solid sector conductors, the round stranded conductors, the sector stranded conductors. These are all shown here with examples of how they look like. Good. Yeah, it is possible, like I've mentioned earlier in the previous slides, to have up to 240 squared cable cross section. Okay, so yeah, so for the connection variant available for the standard option with AC daisy chaining for the Tauro 50s, you can have them. That is for the Tauro 50s. That is for the Eco and the standard. You can have cross-sectional area of 35 to 240. Then for the larger classes, power classes, you can have them from 70 to 240 squared. Continuing with still on the installation, of course, the completion of the installation is signaled by the turning on of the DC switches, which of course allows the incoming DC from the modules to get into the inverter, get converted, and you now have AC on the AC outlet. In terms of the initial commissioning, it's basically a three-step process. A three-step process in the sense that once you have your Fronius Solar Start app on your commissioning device, either a smartphone or tablet, you can go through the step-by-step commissioning process. There's no way you can get lost because once you turn it on, all you need to do is to select the inverter you want to commission, and then through its unique access code, you can of course access the inverter's user interface, and then from there you're going to go through the three-step process like I've mentioned earlier. That is the network, of course, getting connected to the internet, imputing the product particulars and the system particulars, and then lastly, registering the product on our database, which is the SolarWeb. So, like I have mentioned earlier, so all you need to do is to download the app, open the app, and then start the installation, of course, after accessing the Wi-Fi access point of the inverter. And the Wi-Fi access point can be accessed by simply tapping on the middle button of the LED indicator. So once that is done, you will now be required to enter the password. So for now, it is 1, 2, 3 up to 8, but subsequently, probably around Q3 or so, or even before, this password will no longer be used. We would have to make use of the unique access password of the respective inverter. This can easily be found by the side or usually integrated on the nameplate of every inverter. So with that, you will be able to have access to the user interface of the inverter, and then you can now conveniently carry out your commissioning. It is also possible to do this via direct LAN connection, as you can see in this case. So in this case, of course, no password is necessary, but then you now have to enter a unique IP address, which is this 169.254.0.180 to have access to the UI. Of course, the installation wizard, you would have access to it, and then you can now go through, like I've mentioned earlier, this three-step process. For want of time, we will not be able to carry out a demo. It was actually planned to see if we can do a demo, but then because of the hitches we've had so far, I don't think that will be possible. So we will do that in subsequent webinar presentations. So what to keep in mind? Yeah, so please ensure that when entering the password under Windows 10, the link, connecting using a network security instead. Yeah, so this link must first of all be activated, and then this only then possible after this activation to connect with the password. So this is absolutely important. Let's look at the initial commissioning of multiple Tauro devices within one system. So to do this, it is possible to achieve this using LAN switches. So with LAN switches, you can use that to interconnect the Fronius Tauro. Because with LAN switches, with the Tauro, I beg your pardon, we're able to implement the star topology. So with the star topology, multiple devices can be connected to the system, okay? And then even if there is an interruption in the communication link for any one of the inverter, the system still will be up, okay? As the case or of when the implementation is with the ring topology, as is the case with the solar net ring. Because with the solar net ring, if any communication channel or link is broken, then the entire system or the entire loop goes down in terms of communication-wise, of course. So, but then with the Tauro, we have implemented the star topology, which ensures parallel communication and function of the entire system. So even when one channel is down, the rest of the channel is not broken. Let's now talk about the dynamic power control, which is a new feature that will be coming up and be integratable with all our devices. It's a new feature that I'm very, very proud of introducing. So with the system power control, as earlier mentioned, you can use that to interconnect not just Tauros, you can also use it to interconnect with Tauros, Snap inverters, and Gen 24 inverters in our product portfolio, all in one system without the need of third-party devices. So it's something to look out for, and will be coming up in a couple of weeks' time. Good. So for want of time, I will try as much as possible to see how fast I can be to give you all the necessary information. So still talking about network wiring, it is, there are cases where you would have inverters that are at further distances than expected in terms of the range coverable with the LAN switch. So if that is the case, then it is, of course, important to connect what we call repeaters. So these repeaters or amplifiers per se would make it possible for seamless communication with all the Tauros in the system. So for the Tauro, the connection range is 100 meters per communication link. So if you have anything beyond 100 meters, it is advised or recommended that you have a repeater switch, okay, that would be able to amplify the signal coming from these inverters that are further than 100 meters. Good. So this is basically what I was talking about. So in a case where you're going to have an inverter that is further than 100 meters, it is advised that you implement repeaters. So for third-party components, like I mentioned, like the LAN switch that I've mentioned in the previous slide, it is possible to have them installed in this DIN rail, and of course, coordinate the protection of all the components inside the inverter. For export limitation, as mentioned earlier, this is exactly what it entails. So it is possible to have a dynamic power control of mixed systems with more than one inverter. So you can, it is possible to have with just one smart meter as an enabler of this control. You can have multiple devices. It could be a Gen 24 plus, Gen 24, snap inverters, and the Tauro all in one system. All you need is just one smart meter to be able to carry out this control. Now, this is what it used to be. In the case whereby you had multiple devices, was necessary. It was necessary to have secondary meters connected to them, respectively. Or in the case of Tauro, this was only possible with the use of plant controllers, which of course entailed extra cost, as you can see. So, but then with the SPC, as you can see in this case, it is now possible to have seamless control of these components inside one unit. Only thing to add here is that if there is going to be a Gen 24 plus in the system, please ensure that the inverter connected to the battery, that is the Gen 24 plus inverter, is the master of this particular system, in terms communication wise, of course. So once that is done, then you don't have a problem. It's a seamless connection. So basically an overview of the system power control. So you can actually use it to control up to 20 inverters in one system. So if you have a Gen 24 plus in the system, yeah, so that system has to be the master. And then of course the master must also be a pilot device, that is either a Tauro device or a Gen 24 or Gen 24 plus, as the case may be. It is also possible to have a solar net ring in this system. So it means that you can have light inverters and one full inverter per se in terms of communication wise, as inverter with the data manager. So all representing one subunit of this particular system. That's quite another interesting one. So this will be available, say, from the end of Q1. So let's keep our fingers crossed as we await this new feature. And another interesting thing about this new feature is that there isn't any need for a hardware implementation. All you need to do is to update your system to the latest firmware. Once that is done, then your system has the capability of implementing system power control. Great. Let's quickly have a look at monitoring via SolarWeb, because it is one thing to install your system. It is another thing to also ensure that your system operates optimally. And one way to know if this is the case is, of course, through seamless monitoring, which we have made available via the Fronius SolarWeb. So through the Fronius SolarWeb, you can monitor both the production and consumption of all your systems from anywhere you are in the world, so long as you have access or there's internet access. So long as you have internet access, and of course your system are also connected to the internet, you can have a first-hand, real-time situation of all your systems that you have registered on our database. In terms of warranty, yeah, so we have a good news in terms of warranty. So for our region, the Sub-Saharan Africa region, it is now possible to have up to a 10-year warranty for products lower or equal to 12.5 kilowatts power range. Okay, it used to be 2 plus 3. That is, once you register a product, or once you have the product installed, it automatically comes with a 2-year warranty. And then once it is registered on SolarWeb, you now have an additional 3-year warranty, making it 5 years. But now, for products equal to or less than 12.5 kilowatts, we now have 10-year warranty, which is basically 2 plus 8. So that is 2-year warranty for installation, and then with additional 8-year warranty upon registration on our database, that is SolarWeb. Let's quickly go through service and maintenance. So for this, we have unmatched cost savings when it comes to maintenance. This is simply because when there is a case of a service case per se, you don't have to say overhaul the whole inverter or replace the whole inverter. Our inverter comes in a modularized nature, such that these components, these modularized components per se, can easily be replaced right there at site. So take, for example, the power stack, as you can see here. Say one power stack or even the 2 power stack has any issues, you don't have to replace the whole inverter. All you need to do is to come with a replacement. The power stack basically weighs about 25 kilograms, which is possible for one person to actually implement. So one person can actually take it to site and then have it replaced. And I can tell you the replacement is as easy as it comes. So you have your system installed, you're monitoring your system, and then you tend to have some push messages indicating that there are some error codes. Now, it is possible to remotely handle error situations or basically carry out troubleshooting using this Fronius Solar SOS. So with this Fronius Solar SOS, you can actually use it to carry out maintenance, basically troubleshooting and servicing processes or functions on your Fronius Tauro, as it is in this case discussed. Good. Like I mentioned, we have a web-based software, which is called the Fronius Tauro Configurator. With the Tauro Configurator, it makes it possible for you to order the precise device you want for the precise system design. Okay. For want of time, we will not be able to cover this here, but please feel free to visit our website or probably through this link. It is freely accessible, and then try your hands on it. And then get through to us if you have any feedback in this regard or would need any guidance. We will be happy to do so. Great. That brings us to the end of this webinar. Just to give you a few additional information. Recordings of our webinars are, of course, always available on our website. On our homepage, you can have operational and installation instructions. On our YouTube channel, you can, of course, have how-to and installation videos. More specifically, on our Sub-Saharan Africa playlist, you can have access to all the webinars we've ever presented. And yeah, you can have access to them. They're all titled, all fashioned in a way to give you exactly what you're looking for. So let's say you have, you're trying to see how you can properly carry out a system design. All you need to do is to search through our playlist. I assure you, you're going to get a particular webinar that we've carried out or presented in the past that tackles this topic. And then you can go to them and get all the information that you need in this regard. So for further information regarding technical questions, training, sales, and after sales, please do well to contact us using this displayed information, contact details. If you would want to get through to us directly, the TSAs, please do well to contact me, Cyprian Okolo, the Technical Sales Advisor for the Western Africa region, Byron Kutzer, who is the Technical Sales Advisor for the Southern Africa region, and then, of course, David Mwangi, who is the TSA for the Eastern Africa region, also with me on this presentation. So, but then as you are doing so, please ensure that you contact us according to the region that we are taking care of. Okay. Yeah, so that brings me to the end of this webinar. Sincere apologies for the hitches, but then I'd want to say a big thank you for sticking with us up to this time. That is greatly appreciated. If there's any information you need, please do well to reach out to us via email. We will do well to respond and attend to all your inquiries. So until we come your way next time, I want to say a big thank you once again and enjoy the rest of your day. Thank you and goodbye.